All right, here we go. We are on 56A, triangular areas. Let's go ahead and say our Wednesday verse. Blessed is the man who does not walk in the counsel of the wicked, or stand in the way of sinners, or sit in the seat of mockers, but his delight is in the law of the Lord, and on his law he meditates day and night. And he shall be like a tree planted by streams of water, which yields its fruit in his season. Its leaf also does not wither, and whatever he does prospers. Not so the wicked. They are like the chaff which the wind blows away. Therefore the wicked will not stand in the judgment, nor sinners in the... For the wicked will perish. Okay, Selena, garbage. Okay, so on this one here, we're talking about the area of triangles. We started this yesterday. We're going to do a couple more problems on area of triangles. Remember, the key to this was to use your signs in order to figure out what this height is. Because we know the area of a triangle is 1/2 base times height. Okay, so here we do a straight drop down. We do a horizontal coming over here so that we can see that this angle right here is a what?
30.
A 30. Okay, so now that I've made another little pseudo triangle over here, I can find this height because I have a hypotenuse. I can say the sine of 30 is going to be what? Opposite over hypotenuse. Or, we'll call that h, is h over hypotenuse 14. So then our height has got to be what?
20.
14 sine of 30. Now sine of 30 is one that we should know, right? Our sine of 30 is what?
1/2.
It's 1/2, okay? So we've got 1/2 of 14, so the height is 7. All right, so we go back up here, and we still keep our little base here. This is not the real triangle, is it? We use this base, this height, so it's going to be 1/2. The base is 7. The height is 7. The base is 6. We multiply all that together, and we're going to get 3 times 7 is 21, and that is in meters squared because it is area. Yes, Susie?
You got the sign because of what?
Okay, the sine is the opposite over the hypotenuse, isn't it?
Yeah.
We're trying to find this height. And so we can use our trig functions by making a right triangle. See, we don't have a right triangle, but if we do a vertical drop and we do a horizontal come over here, then we make a little pseudo right triangle. And in that little pseudo right triangle, the height of that right triangle is the same thing of the triangle we're trying to figure out. So we can figure out that height, and then we find that. It's the same thing that you've always done, except they gave you that height.
I know, but you said sign. Like, how did you know to use sign?
Okay, because sine is opposite over hypotenuse, and I have the hypotenuse of this little triangle. It was already given to
The
me.
height is the same as the outline line? Or
Of the opposite, it's opposite this angle. See, I made this angle, it's the opposite over the hypotenuse there. Okay, so let's look at this one. And this one is a trapezoid. So since it's a trapezoid, we know that this line is parallel to this line. So I'll do a little parallel line there. Okay, so now if this, we can make this a triangle here. We can figure out its area, and then we'll call this area A, and this one area B, like they do in your book. Okay, so we can make this triangle and find its area, and then we can use this little triangle, find its area, and then put the two of them together. Okay, so since this one, and basically once I find this height here is going to be the same height as this triangle here. It's just flipped over. Okay, so they're going to have the same height because it is a trapezoid and they're two parallel lines. So when we drop this, we can find this height by what? We'll call the A in here because that's the area of the whole thing. This height, H, is what? Sine of 29 is going to be the hypotenuse. Now, I don't know this base. Okay, I don't know this base here. But I do know the hypotenuse of the triangle. Okay, I can find that height because I've got sine of 29 is h hypotenuse, the opposite over the hypotenuse, 5. So 5 sine of 29 is the h. Okay, so this h is going to be 5 sine of 29. Somebody figure out what 5 sine of 29 is. Somebody that's got a calculator. Say what?
2.42.
2.42 is 5 sine of 29. Okay, so right here we can put 2.42 right there. Okay, now that we found that one, we can find the area of this whole triangle, right? This whole big triangle we can find because we have area of A, we'll just call it area of triangle. A is going to be 1/2 base, which is 10, times the height, which is 2.42. Okay, so 5 times 2.42 is what? Area of A is 5 times 2.42, which is, somebody, calculator? 2.42 times 5. Somebody click it out for me. 12 point what?
10.
12.10. Okay. Now, how do I find this B? I don't have its base, right? I've got the base. I could call this the base, though. And I already have the height. So can't I find that calling this the base and this the height, can I find the area of that triangle? Okay, it's just upside down from the way I'm usually used to seeing it, right? But the area of B is going to be 1/2 base, but we're going to call this the base, 4. And its height is still going to be 2.42. So we got 2 times 2.42 is area B. And what is that? 4.84? Okay, so the area of B is 4.84. So I've got 4.84 added to 12.10. So 12.10, because I'm adding the two triangles together, plus 4.84 is going to be 16.94, and that is also in meters squared. And that is correct. Okay, now you make sure we're still going. Okay, and we're going to turn the board over here a little bit. Okay, now we're talking about sectors. And the easiest way to remember sectors and segments is that the sector is the whole slice of pizza, okay? And the segment is the crust of the pizza. A segment is defined as the space in between the arc and the chord that goes through the endpoints of the arc. So basically, if you look at this segment being the slice of the pizza, it's the whole thing, and then you draw a line in between the endpoints of that arc, that crust of the pizza is how I remember it. That crust of the pizza is the segment. So you need to know those two words and what they mean, okay? So now we've got 3 points. O, A, B. This is in your book. We've got radius, radius. Remember, these are both going to be the radius because they're the sides of a sector of the pizza. This is your theta, and this is your height. And we're trying to find this segment over here. Okay? Now, in this book, problem in the book, they give us the theta is 0.6 radians. We're used to dealing with thetas in degrees. But this says theta is 0.6 radians. And then this one, the radius is 10. And we're trying to find this one right here. Okay? So when I'm looking at that, I know that there are 2 pi radians in a circle. Okay? So when I'm looking at the area of this whole sector, okay, if I was going to find the area of the sector, the way we're going to go about this is we're going to find the area of the sector, then we're going to take out the area of the triangle, and what will we be left with? the area of the segment. Okay, so whenever you're doing this type of problem, the process is area of the sector minus the area of the triangle equals the area of the segment. So that's the procedure we're going to go through to get these done. So how do I find the area of the slice of the pizza? The sector. It's going to be what? A portion of the area of the circle. All right, what portion of the area of the circle will it be? Instead of degrees, I know I put the number of degrees over 360. I've got radians. So I'm going to say I have 0.6 radians divided by 2 pi radians. Wouldn't that be the part of the circle that I'm talking about? Okay, so then what would I do? Times, what's the area of a circle? Pi r squared. Okay, so times this fraction times pi r squared. But what's r? In our problem, 10. So what's r squared? 100. Okay, so this right here, my pi's are going to cancel. I've got a 50 here. 50 times 0.6. What's 50 times 0.6? 5 times 6 is 30. Okay, so I can say the area of the sector in this problem is 30. Okay, now what is the area of the triangle? Can I figure that one out? Okay, I've got a theta. It's in radians. Okay, I could turn it into degrees, but I don't have to. What can I do as far as my theta? I'm going to have the area of the circle, the area of the triangle is 1/2 base times height. Okay, now I know my base is my radius. My base is 10. So all I have to do is find out what my height is. Okay, does everybody understand that? So I'm going to move this over here a little bit so that, and can you make room on your desk here? So we have a little bit more room here. There we go. Okay, so hopefully you can see the board. I'm going to move over here and use this board a little bit so we have a little bit more room. Okay, so how do I go about finding if this is 0.6? It is still the sine of 0.6, okay, is going to be the what? Opposite over the hypotenuse. But the hypotenuse is also the radius, right? So I'm going to say is the opposite, which is the height, over the hypotenuse, which is the radius again. Now, put your calculator in radians and find the sine of 0.6. You see that little mode key will change your calculator from radians to degrees and degrees to radians. So you can skip all the hubbub and just put your calculator in radians and find the sine of 0.6. Anybody get that? Sine of 0.6 in radians. Okay, I'll get a calculator just in case. Anybody, y'all try it so you know that that one doesn't have. I need one of my calculators that's got some batteries here. Okay, so I'm going to put my mode. I'm going to go to mode. I'm going to switch from degrees to radians. Okay, enter, switch, and then I'm going to enter that. So now I'm in there, and I'm going to go back and do sine of 0.6. And it is now in radians, so it should give me the right answer. And I get sine of 0.6 is 0.5646. Okay, and then I'm going to multiply it by 10. When I multiply it by 10, what will it do? Move that decimal, right? So I've got my height is 5.646. So now I'm going to take my height and go where? Right there. Because that's going to give me the area of that triangle. So I'm going to put right here my 5.646. I got 1/2 of 10 times 5.646. So I'm just going to multiply my 5.646 4, 6. First of all, I have to multiply by 10 because I haven't done that. And now I'm going to multiply by 5. So now I've got this area of the triangle right here is 28.23. Okay, so process. Area of the sector minus area of the triangle, Duncan, is area of the segment. So I have to take 30 minus this one, right? So I'm going to do that, and I get 1.768, and that should be in whatever the units that was. It should be in square units, whatever those were, okay? So square units. Okay, so 1.768. Now I had put this answer down here, so they got 1.75. We must be off a little bit by something. I don't know, maybe a rounding error. Okay, but that's how you do that type of problem. Any questions on that? Okay. All right, everybody work on your stuff for just a little bit. Pull over your quiz, turn it over, and